Yeah.
So I have uploaded decision tree also, and all the part which we have covered till now, I have uploaded in the Google Drive. Pratik, I have uploaded as you have told me. Sorry for being late. So decision tree I have uploaded, though I told you that I'll upload the example and all. I was thinking as we are short of time, so I can maybe make a offline recorded video of the decision tree example as it's an important part. Maybe the other parts also I'll try to make recorded videos and upload in YouTube so that it will be easier for you guys. Is it fine? And in the next
Yes,
class,
ma'am.
I want to ask you do you want like this only? You want the revision of what we have covered, and what are the next part we can just overall like cover by MCQs or so? Like how you want the last class to be? Because it's a last class, I don't have
We
any.
can we can cover MCQs, ma'am. You don't need to like teach us the maths anymore. I mean, first 6 weeks were maths. Just
Okay,
revision
okay.
and MCQ would be great.
Okay, today we'll cover evaluation measures because I have now I have taken for today because I don't like have the MCQs for the other part till now. Maybe I'll prepare the MCQs for the remaining part as well as the MCQs which we have covered also for that part also, the mixed one, and I'll explain with the help of the MCQs. And if you want, then I can make the recorded videos for you guys so that it will be beneficial for you with the part which we haven't covered and you find it's tough. Or if you find
That
if
that would be fine, ma'am. If you have the time, sure.
yes. When is your exam?
25th. All of us are 25th.
Then it's fine. I can make till 25th. Okay. One thing I promise I'll make the recorded video of the decision tree example before Tuesday only, so that you can give me the feedback. You got that example of the decision tree. Earlier, I was thinking to upload the notes only. Then I thought, okay, let's make an example and upload the recorded video of that decision tree example because it's an important part. So let's start. Let's not waste the time and start today's lecture. Any other person who wants to give the feedback regarding the next class? Yes. Megha, Pratik, Trishay. Any feedback? Formula sheet. Oh, okay. Okay, I'll try for that also. And please, I'll suggest you guys, please, someone can share with me, whosoever, because you guys all are learning. So, anyone who has made the formula sheet, I earlier also told you, make a Google sheet. I'll also upload you. You can also upload those on those sheet. Everyone can contribute. Is it fine? Let's make a Google sheet and share it with me, mail me, so that everyone can contribute in that. And okay. Is it fine?
Yes, ma'am.
Okay. So let's start. So coming to the evaluation measures. Uh, in supervised learning, like we have done that in supervised learning, we don't know the underlying distribution. It is a true distribution which we don't know, and we have to find a true error basically. So how we find usually the true error? Uh, like we do the expected error under the true distribution, but the true distribution itself is unknown. That is the main issue. That we have done initially only. Like true distribution itself is unknown. That is the main issue. We don't know from which distribution. Like we all have done before starting the linear regression. If you can recall, like like true distribution is unknown, how we can do, and all those steps we have covered initially in lecture 2 or 3. Now, then we did, okay, let's take the expectation and all, but we need to find what is the true error. Then only we can basically find it. So, what are the ideas? What we can do it? So, first naive idea, very simple idea. Use the training error. Train your decision tree on all the data. Check the accuracy. But what is the issue? Obviously, if I'll have one decision tree, one training data set, I'm saying is, okay, Okay, okay. What I'm saying is I'm having one data set, one whole data set in which I am training, in which I am testing, which means I'm not having any testing data set. Now, what can be the disadvantage of having only one data set? Any idea?
If we have only one data set, we'll never find anything to test it with.
So what I'm saying is I'm testing on the same data set. What can be the limitations of testing on the same data set in which I have trained?
We'll not test anything, ma'am. We'll get the same answers at the.
Which means I'll get 100% accuracy. Can I say
Yes.
why? Because I have because my model will learn it because my model already have seen that examples. Like I want to test it on the unseen examples. Then only because it will memorize it. It has learned already those examples. If I'll make them test on those same examples, then there is no benefit of that. Can I say? So that's why we need to have actually. Okay, the second idea. First idea was the naive idea that okay, use the training error only, train it and test it on the same data set. Like training and testing, they are all the same data set only, which will lead to obviously the issues like the 100% overfitting and all those, and it's no use basically because our model has already memorized it. Second idea, take the large data set, train and test on it. Will it be beneficial? Okay, I thought okay, I'll train a data set. Will it be beneficial by making a data set larger in size and training and testing on that? Is there any point, or it will have the same limitations? Anyone? Come on, come on.
Would you kindly repeat, ma'am?
I said earlier, I have a training data set, a same data set in which I'm training and testing. Now, what I'm saying is, why not just take the large training data set and test on it? Will it be beneficial? I don't think so. By making the data set large and training and testing again the same limitation will be there, the overfitting. And I'm already memorizing whether it's large, whether it's small. It doesn't make any sense. Large data set will also not solve the issue. Can I say?
I would have expected, ma'am, that you would divide into 40, 20, 20, or 40.
I'm coming to that. I'm coming to that.
Yes.
Yes, that is a better idea, as he said. Like, let's separate our data set. As like this we usually do now, that we are taking a data set, we are splitting that data set, either 60-40, as he said, or 70-30. Let it train on the 70% of the data set which we have chosen, and let it test on the 30% of the other data set. So that we should know that on unseen examples, how our model is performing. Because our model has already learned the seen examples while it was training. Any doubt till now?
No, ma'am.
No. Okay, fine. So, but there is an issue here. Can someone tell me what can be the issue in splitting? We usually do splitting. What can be the issue here?
We will not have the same kind of data like stratify we use.
Yeah. Can you repeat? We'll not have the.
And we will not have the same kind of data. Sometimes in our data we have something just,
Yes, yes,
just
yes.
like ma'am in coding we use stratify.
Yes, 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 yes. Exactly, exactly. So Gaurav is also correct and you are also correct. So he's saying skew in data, Bayesian data. So it may be the split may be lucky or split may be unlucky, I can say. So uh, like what I'm saying is, if the split is unlucky, which means that the 70%, now my performance will depend on the 70% which I have chosen for training. Can I say? What I mean by split is unlucky. Come on.
No idea, ma'am. I don't know about unlucky.
Okay.
I think, ma'am, we have one kind of pattern in our training set, but we will have another pattern in our testing set.
Yes, yes, correct. So it may happen. I split. I may have easy points in very layman language, easy language. I'm saying that I may have easy test points, easier patterns, or some patterns which may be which like what usually is happening in training. I'm not learning the actual example. I'm trying to figure out a pattern which I'm learning. That is what is happening. And then when I'm testing the same pattern which I have learned in the training. So it may happen that 70-30 split is unlucky. 70-30 split is unlucky, which means that maybe it is missing some pattern when I'm splitting it in 70-30. So it may happen. And then 30% when I'll check in the testing. So it will give me bad accuracy because I haven't learned that pattern in that training data set. So it depends on the single split. Can I say? Anyone can tell me, is it fine or any doubts? Come on, come on, class.
Fine, ma'am.
What about others? Megha, you were very interactive initially. What happened? Yes, others also. Gaurav, fine. Sachin?
It's fine.
Yes, madam. It is fine until now.
Uh-huh. So that singles, we can't depend on single split. It means that 70% I'm saying that I am using it for training. Maybe that data set is not that good enough. Maybe that is missing some patterns. I'm depending on single split, na? Yes, Gaurav, any doubt?
No, no, ma'am, no doubt. Sorry, it's
Mhm.
unpaid.
Okay, it's fine. So what can be the solution? And what is variance here? I'm saying that I have written here there is a high variance. So MCQ, another MCQ which can be there. The single split can have high variance or not. Yes, it can have high variance. Now, can you explain me how high variance? Yes, come on. What is variance? You know, na variance bias. I have explained you. Variance means the yes, yes. Come on,
Yeah, variance is basically data is
right.
distributed. Yeah, spread across. Yeah.
So now what I'm saying is the variance is high here, like among the test accuracy and all. So what do you mean by that? Why it's high? Can anyone, by the single split? Can anyone tell me? Come on, let's try.
Ma'am, it would be that most likely because one the extreme data is only in the one of the sets and the other one has does not have the extreme data. For example, the plus of minus 5% of the
Okay, okay. Okay, if I talk about accuracy part, variance is high, then I'm getting you are talking about the data set. What I am talking about is the accuracy part. Can I say I'll get sometimes very high accuracy, sometimes very low accuracy when I'm splitting? Does it make sense? Can it
Yes.
happens? Can it happen?
Yes.
Yes. What about others? Yes, yes, Sachin. Yes. What about others? So maybe one training testing split, maybe I'll get very good accuracy because that training point where I split that 70% was good enough to capture all the patterns. Whereas in other, when I split it again, I tried to split it again, I find out, okay, that is basically giving me not that good accuracy. That accuracy, basically, what is that accuracy? That is the estimate of a true accuracy, can I say? A single training test split give high variance estimate error, I'll say, of the test error. Now, what can be the solution? Can I say I'll take multiple training data set? First one, what I told you is let's take a single data set and then let's do training as well as test on that. But we saw that there was an overfitting because we have already seen examples and already seen already testing on the seen examples. Obviously, they'll give us no benefit because it has already memorized it. The second idea we thought of, let's make that data set large, but it's of no use, we find out. Then the other was, let's split that data set into training and testing and train on another data set, test on another. But that split can be lucky as well as that split can be unlucky as well. So we can't depend on single split sometimes. So now the other solution I came up with is, we came up with this multiple training data set. So what I'm saying is, train model on each data set. I'm having multiple data sets. Let's not take, like here I was taking a single data set. I was splitting it on 70-30. Let's take multiple data set and test on fresh unseen data. Each data set will have like different error. Someone is having something, someone is having something, and then I'll average these errors across the data set. That will be my true expected error. Any doubt in this approach? Yes. Any doubt in this approach?
Is this the bootstrap approach, ma'am?
No. I'll come to that. What I'm saying is, I'll come to that bootstrap. It's not bootstrap, but it's similar to bootstrap. Gaurav, I'll come to that. Here I'm saying is, let's take multiple data. But in reality, we don't have so much of data sets, we don't have multiple independent data sets for a particular problem. So that is the main issue. I can't take many data sets. So here also, there is an issue here. So we have seen an issue here as well in the splitting. In multiple training data set also, we saw some issue. Now we came to the bootstrap, which is a solution. Understood? Please give thumbs up if you have understood. Then I'll come to bootstrap. Come on. So Bootstrap, can someone tell me if you have read about it? What is Bootstrap?
It is kind of a resampling payload.
Yes, Shyama, is it? Yes.
It is kind of a resampling.
Yes. Exactly. It's kind of resampling. So what we are trying to do is, he is absolutely correct by saying this. So we are taking an original data set, suppose with an n samples. Now, these are bootstrap samples. I'll come to it. What I'm trying to do is, maybe I'll come with an example. These all are, okay, maybe let's first see the example, then I'll come to that theory part. So this is S and these are bootstraps and this is out of bag. Now can you read it and can you tell me, as he said, what is this S1 dash S2 dash? If I'm saying these are basically bootstrap samples, these are actually bootstrap samples. What I have done here exactly?
In the previous S1, I think 3 is taken out, and I think 3 will be, and second one, the 1 is taken out.
Yeah. So what is this? This is out. This is called out of band. Though we are sampling S1 dash, we are making multiple data sets. Now, as we saw that, okay, multiple training data sets, it do solve our problem. How it solve our problem? Because when we'll train on multiple data set and test on fresh unseen data, and this we'll average the errors across, it will solve our problem of like lucky split, unlucky split. But the problem here was, I was not having multiple independent data sets. So we thought, okay, let's take a single data set and make multiple data sets from this only. So how? We basically sampled it. We basically take, this is of n size. Suppose this is of 5 size. So what I'll do is, I'll sample it from this original data set. These are called the bootstrap samples. They're sample with replacement, which means I'm taking out 1, I'm taking out 2, then I can again take out 2, or I can again take out 1. So that is called with replacement. So some they can appear multiple times and some may not appear at all. And which are not appearing at all, they are called out of bag. So here I have created two bootstrap samples, which means I have created multiple data sets from a single data set, which are mimicking, which are actually like,
But
or which are the
replacement here, ma'am.
yes, yes, yes.
Where is the replacement?
Okay. Can you tell me the difference between with replacement and without replacement?
No, I'm thinking like from the first one, the three is taken up. Oh, three
Hmm.
is
No,
replaced
no,
with
no. 3 is not taken out. S1 dash is taken out, and whatever is left is 3 out of bag, which means
okay,
it is not in bag. It is not in our sample.
correct.
Hmm.
Now instead of three, we are putting two, right?
Yes, yes. Actually, it's like, don't see this out of bag thing. It's like 1, 2, 3, 4, 5 is given to me. I have to pick out 5. Like, suppose 5 slips are given to me. Like simple, 5 slips are given to me. I pick out one slip, that is 2. I'll put back the 2 again to that slip. Now there is a probability that I can like pick up 2 again. Na? So putting back again to that bag, that is basically with replacement.
Yeah, ma'am, one question.
Huh.
See, from 1, 2, 3, 4, 5, I'm just okay.
Mhm. Yes, yes, yes. Continue.
5. Okay. Now if three is taken out, for example. Now we have the one, okay, 1, 2, 4,
No,
5.
no, no. I'll again put 3 back. That is what with replacement means.
Ma'am, I have just one question. When I saw Bootstrap, I thought it was like you put everything in a bag, mix it up, take it out, record it, and then put it back and take it out.
That is what I'm
I
saying.
I I thought it was random, but the way you're saying it, it's not random. You did that on purpose, making.
No, 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 no. It's random only. I'll pick it up.
Okay.
Suppose I'll randomly pick it up. Pick one number, that is 2. I'll put it back. Now again I have 1, 2, 3, 4, 5. I'll again pick it up. It's 1. I'll again pick it up. Maybe it can be 2. So it's random only. You're right, Gaurav.
So we have to keep on doing this until the error minimizes.
Basically, we have to make, no, no, no. It's like I have to make multiple bootstrap samples, which means multiple data. Okay. Suppose I make 3 data sets out of it. So it can be anything random. Suppose it can be this also, all ones. It can be all unique, or it can be mix match. Okay. Any doubt how we have made bootstrap samples? Then I'll move ahead. Any
No,
doubt?
for the S1,
Hmm.
if you change with the one and if I change with a in 5 times, what does it different? How does it different? That is my question.
What I'm saying is they are random, as you
Correct.
said. That is just an example. What I'm saying, I pick up one, again I put it in the bag. Then I'll again pick up any random thing. That is again one. It can be again one. Are you getting my point?
Okay.
So these are all are random. These are basically random examples, but they have to be of size n. Whatever the size is of the original data set, the same size should be of my bootstrap samples. So that it should mimic, it should
Okay.
be the clone, it should be, sorry, not the clone, it should mimic my original data set. Please give thumbs up if you have got the bootstrap samples. If you haven't got, how to what are bootstrap samples, ask me again.
Ma'am, just one question here, a couple of questions. One is how many such bootstraps
Uh,
uh, we can do, number one, and number two, why to limit it to n? I mean, if after all the intent is to increase the accuracy of prediction,
mhm.
uh, then we can increase the number n as well until we get the expected accuracy.
Can someone answer his two questions? What first he's asking why to limit. Okay, first let's say he's asking why to limit up to n. The second one he's asking how many bootstrap samples. Yes. Can someone tell me? Come on.
I guess that look, when we wanted multiple samples, but we have a very small we have a small data set, so that's why we are. This is sort of a trick in order to make more testing sets?
Mm-hmm.
I did not think that there's a limit to how many sets you can make.
There is no limit. It's up to you how many sets you'll take, how much time, how much computational power you're having. It all depends on you. There is no fixed universal rule or any reasoning about how, in practice, how many bootstrap samples you'll make. Second question, I want to mimic it like my original data set. I want to make this bootstrap sample the same as my original data set so that my all mathematical questions, all the computations, all the accuracy, all the something like all these things should have the same part. I want that this should look exactly as my original data set. Though I'll come to this, why I want that it should look exactly as my original data set. I'll come to you. I'll come to you. Maybe I think I have answered it in the further slides. So that's all. Fine.
Okay, okay.
Now what we'll do, as I've told you, okay, I have made bootstrap samples. Now, what is the next step? I have told you only. Come on, what is the next step?
To test the model.
To test the model. Then whatever the error is there, then what I'll do? Each of the data set I'll test with some model. Then
You take the average error. Take
yes, hold it as error 1, error 2, error 3. Then I'll basically average all of. Is it fine?
Actually, we should use the dataset with minimum error.
No. Why not minimum error? It's not we should use with the minimum error. Maybe it's overfit.
Ma'am, S1, S2, S3 we are using to train the model, right?
Yes. Then I'll have the testing. Haha. Okay. And here I'm talking about only. Okay, wait a second. Here I'm talking about only training part. Wait a second. Maybe. So anyone can answer. Is it used for training or testing? I'm also confused.
I can both.
Okay. Yes.
For both.
It's the original data set only, which we are basically using.
It was for training, right? I mean,
Can someone answer? Both training, testing? Yes.
I can. I think, ma'am, it's for both.
Okay, how how it's for both? Can you explain
Ma'am,
same data set
first,
for testing? Or
first we make, ma'am, first we make a lot of samples,
Hmm.
and we will feed if 60% or 70% to our training set, and then the remaining part will be go for testing.
So can I say out of bag is going for testing?
yes.
Yes, exactly. These are called out of bag. The points which are not included in the bootstrap samples, they are basically going for testing. So these bootstrap samples, can I say it's for training? Training set is bootstrap samples. And one more thing, you will notice in bootstrap sample, 63% of the unique data points, like here I have taken this, like, can I say here 2, 3, 4, 5, they all are for testing. Are you getting confused?
The
Yes,
last statement, what did you say just now?
can I say the out of bag data points are used for testing and these bootstrap samples, they are used for training?
I think it is other way around because testing data is always smaller as compared to
So
training
out of
data.
bag is lesser, na?
It is only one sample
No,
or
it's
one
one
set of
sample
sample.
here. It's one sample here. But if I'll have thousands of them, then it will not be one sample, na?
Yeah, I
It's
mean, the set of samples will be smaller as compared to training data set.
yes, that will be smaller. It is smaller, na? Out of bag is testing. Bootstrap sample is training.
Yeah, so Bootstrap for training and out of bag is
Or
for
testing.
testing. Yeah.
Yes, what about others? Are you getting? Yes, Gaurav, Pratik, Shamal. Yes,
Writing it down, ma'am. Bootstrap for
Okay.
training and outer bound for testing,
out of
right?
back, out of back. Yes,
I
maybe.
got
Yes, okay. So when we okay, though he professor have not mentioned it, but still, like usually we'll see. I'll not go in depth of this. Usually we can see that on an average we'll see that 63% of unique points will be in the bootstrap sample, and 37% will left for the out of bag. Though I'll not go in deep. So there is one research which says this. I'll not go in depth that testing data set will left with 37% and training will be 63% unique points. Like, do you got what I'm saying?
Yes.
This is a mathematical result. Let's not go deep. So we have now understood. I hope so. You have understood what is bootstrap sampling, how we are doing this. So, what can be the limitation here? Now we have done so much of multiple training data sets.
There'd still be high variance, right? If there's anything wrong with the data set itself, it would, no matter how randomly you pick and make multiple data sets, it would still be high variance.
But we have taken so many data sets now.
Okay. Extreme, I thought extreme data sets would still appear.
Extreme would appear, but we are averaging it out, na?
Okay. Okay.
Ma'am, just one question. When we convert one set of data into
Hmm.
multiple sets of data to improve the accuracy or to lower the variance during testing, so will
Hmm.
it also lead to higher computing power and other challenges of very high data?
Like obviously, I'll not say converting will cover, but obviously, if I'll say I have to train it on multiple data sets, it will take more time. If I am training it on one single data set, it will take lesser time and lesser computation. Whereas when I say about multiple bootstrap samples, training it on multiple data set, multiple bootstrap samples, it will take more computation power and it will take more time. Though conversion of bootstrap samples, it will not take much.
Mhm. Okay.
Hmm. So there is an issue with the smaller data set. Can you think why the smaller data sets it's not good? Bootstrap samples, bootstrapping is not good for smaller samples. Though your answer was correct, high variance. I confused you, but why high variance? Because of the smaller data set. Now answer it, Gaurav.
No, yes, that was.
You were saying it's you like the answer is though it's correct when I have smaller data set then I have very I can say then the variance can be high then I because I'm having very lesser training points now. So if I'm having like this is a smaller data set only, so I'm having lesser training points, lesser out of back points. So some samples are repeating multiple times. So overfitting is also there can also be overfitting and all those things. And maybe bootstrap estimate it can become I'll say if I have very few unique points also. You suppose like here I have very few unique points in this case. Then the model will become highly unstable. I can say high variance is there. Though in that point, averaging will not help us if the data set is small. Though your answer was correct that still there is an issue of high variance, but why? Because of the smaller data set, not the skewed or something. So Bootstrap works best for moderate to large data. For smaller data sets, we don't prefer Bootstrap because there can be the cases where I'm not having unique data points in the training data set. There can be the cases where I'm not having for the I'll say there can be because of this not unique points and all. The averaging effect will also cancel out and we'll have more bias, more variance. So more testing error over, and the other thing is overfitting risk can also be increased because same sample is repeated multiple times. So okay. So
Well,
further,
ma'am, just a thing. Now, at the start of this session, we discussed that because of single data set and this training data and testing data split, there are certain limitations, and that's the reason uh, we chose multiple data sets, and that's how Bootstrap has came into picture. So
yes.
I think originally we discussed that there is certain limitation of a single data set, which
Mhm.
was which the one of the reasons was the same variance, and now we opted Bootstrap, and again we are saying there is a limitation of variance,
Hmm.
and
Okay.
that limitation is because probably we are limiting it again to the n number of points.
No, no, not n number of points. What I'm saying is this n is small in number. Sometimes this original data set is small in number. Though we have solved the problem for the medium data sets, large data set. But if the data set is very small, then again Bootstrap is having the same issue. As you have told me that ma'am, the split issue was there, that there is a high variance. But ma'am, the same issue is there in the Bootstrap also. Yes, there is the same issue, but when we come to medium data sets or large data set, this issue is not at all there. This issue is only there when we are taking very small data. For
Okay.
that, we have to come up with some other approach. But when we are working with a medium data set, medium size data set or large size data set, Bootstrap do work very well.
Mhm, mhm.
Then there is no issue of variance.
Okay, okay.
Fine.
Yeah. So just Bootstrap reduces variance to certain extent, but again, it works
Smaller
well with,
data
yeah,
sets.
exactly. Yeah, understand.
Now, for that, again, another approach came, that is the cross validation. Can someone tell me what is cross validation? Come on, come on.
We are splitting the data into some equal parts.
Yes. So basically, what happens is, anyone else want to tell? Yes. So cross validation is, we usually term it as folds. We are basically like k-fold cross validation. So like how many fold cross validation? I'll come to this fold when we'll see this example. Then maybe we'll come to this theory. What we are doing is each time we are training on k minus one fold and testing on remaining folds. So it is also resampling technique, I'll say, used to estimate testing error. But how we are doing? Let's try to understand. So what I'm doing is, I'm k folds, instead of k folds, I'll say I'm dividing my data set into k equal parts. Okay. So that parts is actually the fold here. So let's say that this is my data set. Let's try to come up with the example and try to understand it. So this is my data set. I split it into five folds. When I split it into five folds, this is called five-fold cross-validation usually. Like how many fold? Which means I have split it into five parts. Okay. So this split we have done. And then the next step, train on k minus one fold, test on remaining folds. Now can someone tell me what I have done? Yes. Try to understand with this.
Yeah. So basically, from the same data set, for testing, we have chosen different set of samples.
So what I have done, yes. I have basically from five folds, what I have done here, I have taken four folds for training and one fold for testing. So suppose in round one, I'm doing multiple rounds. So in round one, I take okay, this fold two, fold three, fold four, fold five, fold two to five for training and fold one for testing. Then in round two, I'm taking one, two. Okay, wait a second. Okay, fold 1, fold 3, 4, 5 for training, and fold 2 for testing. Round 3, what I'm doing? I'll come. If you're not able to understand, I'll come again. We are not doing 70-30 split. What we're doing here? Can someone tell me how it is helping me with the bootstrap? Can someone explain me this example first? Okay.
You're you're just creating equal number of you're dividing it into folds with equal number of samples in it, no replacement. And then first you're using all but one to train it and then one to test it, and then you're doing it multiple times with different
Hmm, hmm,
folds.
hmm. Are you getting it, the intuition or not?
I know
Up
what
to
you're doing, I
four,
don't know why you're doing it, that's it.
Okay.
up
What
to
about?
fold, it was clear. Step two.
So what I'm trying to do is I'm splitting into 5 folds. Okay, Gaurav, is the bootstrap part clear?
Yes.
Till that it is clear. Okay. Now cross validation, we are finding the difficulty. Let's try to understand. So let's try to split into 5 folds. What I'm trying to say is I split it into 5 parts. I took the original data set, split it into 5 parts. Fine. Is it fine?
Yes, ma'am.
Now what I say, let's take let's take out of these 5 folds, 4 for training and 1 for testing in every round. Fine. So what I'm trying to do is, let's take, suppose I randomly take any fold. Like in the first round, I took uh like fold 2, 3, 4, and 5 for training and fold 1 for testing. Fine. Is it fine?
Yes, ma'am.
What about others?
Yeah, ma'am, these folds, we are basically reducing the size of training data.
I'll come to that. No, nothing like that. Nothing like that. Fold is just, it's like not reducing, just like I have partitioned my data set into multiple parts. I'll come to the intuition afterwards. Like, are you getting what I'm trying to do here?
Yes, ma'am. And I guess, ma'am, it's a ma'am, technique to train
It's
our model.
it's a technique. So, Pratik, are you getting how? What is the technique here? Yes, come on.
Yes, ma'am, I'm getting.
Hmm. So, what I'm trying to do is, Gaurav, fine or no?
The technique is clear, just the why.
Clear. Intuition is not clear. Is it like that?
No, in the sense I know what you're doing. I can see like you're making folds and you're uh, training in all folds and testing in one fold for once, and then again you're taking the same model and doing the same thing, but you're taking a different testing fold,
Different
and like
training.
that you're doing it multiple times, and then you're taking the error and averaging it.
Hmm.
I just don't know why, and how is it different from bootstrapping
Okay. Now, can someone try to understand? Okay. He has
in terms
done
of results? In
in
terms
terms of result. Yes. Now, can you think what is the difference between them? Okay, you told it very correctly. We took a data set, we divided into parts, we train on some, we test on some part. Is it like that? The overall, the broader intuition, the higher level picture is that, okay, what we have done, higher level picture is we took a large data set, we split it into training and testing. That is what we have done. Again, we took a larger data set. In the next round, we again took some training and testing. Fine. Now, can you try to recall again Bootstrap and tell me what is the difference? Can some?
bootstrap we had replacement over here. It doesn't look like there's a method to this that was random.
This is also random, na? Training on randomly.
And I guess it's faster than Bootstrap.
Yes, it's faster than okay. What on the terms in terms of variance, it's low variance. Why it's low variance? It's without replacement. Okay, as he has correctly mentioned. How it is low variance? Okay, what we were trying to do here, we were trying to basically reduce the. We were saying okay, in smaller data set, it will still have higher variance. But how that problem is resolved here?
because because we are using unique every time.
Yes, 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 yes. You got Gaurav what he said? We were not using
We are
unique.
using a unique every time.
So we were not using unique here, unique data points here, which can cause overfitting, which can cause the because that for that point we were having the overfitting issues, more error. The model was not trained here in like this case properly. But here we are using the unique. We are not doing any replacement, and we are also doing multiple times also. So it is reducing because every data point appears in test set exactly once, appears in training set k minus once, like or I can say they are using uniquely.
Yes, ma'am.
Okay, is it random?
I think that splitting is not random, but choosing the fold is random.
Using the fold is random. What about others? What do you think?
Nothing is random here
Hmm.
because you've created the folds. Maybe the folds themselves are unique. The testing you're doing on each and every fold once.
Hmm.
It's not random at all.
Okay, what about others? What do you think? So exactly the random variation basically it's not there. We are basically testing on everything, training on everything. Though how you form the okay, that is basically leave that part. So basically we are doing everything testing, training. So so that everyone should come in testing, every unique data point should come in testing. That is what we are trying to mention here. That is why we are not getting that much of variance as well. Any doubt? Come on.
No, no.
I'm not getting that energy from you guys, that enthusiasm today. Why? What happened? Extra class, second last lecture. Yes, you all should participate. Yes, everyone. Is the are the things not clear or the way of explanation is not clear? Yes, be
No,
vocal.
no. Actually, it is explanation is very good, ma'am.
Hmm.
And even I would say understanding is also good. Uh, for me, the only concern is how it is really reducing the variance. Because actually, see the first bootstrapping,
Hmm.
we said that bootstrapping is actually the training methodology, right? And out of that training set, that OOB out of box set we are using for testing. Okay.
Hmm.
And then we saw that there is some limitation of variance in case of that bootstrap technique. And then we started discussing this next method. We are actually talking about validation. So,
I'll
I think there may be little disconnect here because we discussed that training methodology, bootstrap, and then we suddenly uh, talking about some validation methodology, and that we are saying it is how it is reducing the variance. That is also not very clear. But probably, I think the maybe when we will actual work or we handle some data or we apply this
No,
technique,
no, I'll
probably
come. I'll come.
we can understand.
No, no, I'll solve your question now only. Like what happens like in bootstrapping, we are We are having the data set where
Ma'am, you may just check whether the same concern others has, because I don't want to spend everyone's time on just my
Fine, fine.
concern.
No, no, it's fine, it's fine. So I'll not take that much of time, don't worry. So it's like for bootstrapping, it's like repetition is there because we are having with replacement. Does it make sense? But in this cross validation, this with replacement part is not there, which is basically reducing the variance here. Can someone tell me, does it make sense or how?
Yeah, just I mean, before someone jumps in, I just want to now you can you scroll up to that just now you wrote on the screen, the one. So this left side is bootstrap, right? And then other side is K
This is
fold.
all bootstrapping. This is no. This is all bootstrapping. This is bootstrap sample. This is out of bag. So which means I'm training on this. I'm testing on this. So
Okay.
here, obviously, the variance is there because
Okay. So no, no, I think the
data
basic,
set. Huh.
yeah, basic. I got the basic confusion. So actually, out the on the upper pages, you out of box sample, it's something which we have not used in boots. I mean, the we took out from bootstrap and then we use, but here we are saying bootstrapping basically one data set we are repeating it,
Huh. Yes.
and
One
whereas
point.
the K
Point.
fold we are not repeating that data
Yes.
set.
Yes.
Okay.
I would have, ma'am, also. I don't want to dwell on this, but I would have thought it did not work because again we're using a small data set, and the
All data.
pattern. All these are small data sets, so inherent variance will always be there.
I agree to your point, but what I'm trying to say, okay, why small data set bootstrap will not work? Can you think about
But
it?
they will work, ma'am. They'll just have
They
high
will work.
variance.
They'll just have high variance. Why?
Bootstrap
Because
and K-folds are like sort of a. Okay, no, please, ma'am, continue. Why?
no, it's fine. It's okay. Okay, just think about it. That why if I take small variance in k-fold cross validation, then the variance will not be high. But in Bootstrap, it will be high.
No, that part I got, and difference between two I got.
Huh. Now there is a problem in class.
Just sorry, just one doubt. Now in Bootstrap, we are actually we are repeating. So in this example, we just saw that this one data set we have repeated for five
Data
times.
point.
But
Yes. In
but
k-fold, we are not.
no, just a minute.
Yes.
Here, this multiply by 5, but even training, when we will train, if whether we train on one sample or same sample 5 times, the training will remain same, ma'am, right? I mean, how it will change the training results by repeating number of samples?
Here, what
Eventually
no,
training
no,
result will remain same, right?
it's not learning 2, 3, 4, 5. It is not learning, na? Other patterns, it is not learning.
Now one we have 1 2 3 4 5 for training, okay,
We
which
don't
is
have, we
actually
don't have, we don't have, we don't have.
no,
In
no, originally we have originally.
now I'm
I
take
mean,
bootstrap sample. I took all ones here. Then I'll not have 2, 3, 4, 5. I'm not learning that.
but the result will, if we do one, the train on only one and then train on 5 ones, the result will remain same, right?
Same, but on testing, the result will be very less on 2, 3, 4, 5 because it doesn't know how to learn 2, 3, 4, 5.
Okay.
Getting it? It is not. It has not seen the patterns like that.
Yeah, so I will just ask another question. So suppose we did now this, there are this training data set bootstrap is 1111, and then this is the other side is testing data. Now
Mhm.
I got some variance. uh, when I will execute it, I will get some variance, and then I will do 2222, and then I will train maybe 1 3 4 5, and then I will get some variance, some parameters. So after doing these 5 iterations, will I going to pick the best
Great average
model, and
error.
then I will use it in my future references?
These are all same model. These are all same model. Bootstrap uses same model on different data sets. Everyone. Are you getting? They are using same model on different data sets. Now, on different data sets, I'm basically calculating what is training, testing, I'm calculating the error, and then I'm averaging that error. Shamal, got it?
Yes, ma'am. I got it.
Yes, Sachin? Okay. Sachin was speaking. I'm sorry.
Uh,
Sachin, yes?
no, I am also okay. Maybe we can proceed, ma'am.
Okay.
Yeah.
You're still having any doubt? Then, or
Yeah,
is
yeah.
it clear?
Maybe I will email or maybe
Okay,
we'll
email.
discuss. Yeah.
Though I want that you should be clear, but we are short of time. Sorry for that. Though they are the same, I'll talk in short that we are having same model with the multiple number of data sets, which are only the mimic of the original data set by resampling. Fine, Sachin.
Yes, ma'am. Yes.
So there is a problem which occurs in classification. Can someone tell me what can be the problem?
Random split would be again the thing I said, high variance. Imagine if you're taking like one data set would have all the very extreme values, like the 5% plus or minus of the extremes from the mean. What we
Yes,
call value at
yes,
what
yes,
risk?
yes, yes,
Yes.
yes, yes. Exactly. So, so suppose I'm having very few class B samples, model won't learn about it. Like as you can see that, suppose again, okay, you were talking about this small data set in this part. What I was thinking was a data set is small. Here, what I'm trying to say is the split is like this. Like I have very almost all class A's, whereas very few class B's. Are you getting my point? It's not about small data sets. It's about small class. Gaurav, does it
Yes.
make sense?
Yes, ma'am. Yes, ma'am.
Hmm. Yes, Pratik, Shyamal, Sachin, yes,
Ma'am.
Ishay, yes. So, now, what I'm trying to say is there is a skewed distribution, I can say. The classes, it's like that. Like very few classes B, very large classes A. Then at that point, we can have basically uh, like here for testing, it can't evaluate well when I'm having these type of distribution. So the solution here is stratified sampling. So what I'm trying to say is each fold have same proportion of whole data set. So suppose in each case, I'm having 90% of A and 10% of B. Can someone explain what I have told you? Like, suppose you have, yes, first you can tell me what do you mean by stratified sampling? Okay, we got to know, okay, in classification, this cross validation, it may have some, because of a random split, there can be an, uh, like, problem here because of unequal, I can say unequal class distribution. There may be few or no samples of minority class. Mostly one class is dominating here. So now we can't learn the minority class properly. So for that, we have stratified sampling. Now, can someone tell me what is stratified? So what I'm trying to say, let's split the class for each fold which has roughly the same class proportion as the entire data set. If I'm having the same proportion in my original data set, like 10 are A and 2 are B, then take the same proportion in my sampling also. In my sorry, in my this folds as well. Any doubt?
No, ma'am.
Okay. Now let's see this these MCQs. Let's start with that. So for okay. Write this 41, 42 because I made the whole PDF and then I have split it up. The true error of classifier is defined with respect to write 41 and then the answer. Come on. Please write in the chat. Sachin, please write the question number as well.
Is the training data only? Sorry, test data only?
Right. I'll tell you. Just wait a second. 1 minute. Okay, let's see. 41 BB. Wait, it might be C. Okay. B. Wait, it might be C. It's actually C. True error is defined with respect to underlying distribution. That is what I was telling you, that it depends on the distribution which is unknown to us. Remember or no? True error is defined on the underlying distribution which is unknown to us. We have done the joint distribution and everything. I'll tell you, please go back to the lecture 3 and 4 again to refer this. Why we have done here also joint distribution and everything. I in the starting of the class told you that yes, Trisha, your guess was correct, and Kaleswali, you are right here. So maximum have answered B. No, it doesn't depend on test data set. It depends on the true distribution. Why can't we directly compute the true error? Now this is obvious. Come on. Come on. Be fast, exactly, because the underlying distribution is unknown. If we use the training data to estimate the error, the estimate is usually unbiased, optimistically biased, too low, pessimistically biased, or equal to true error. Pratik, read the question properly. If we are training data on the same, like if we are using the training data to estimate error, so which means optimally biased, which means the error will be low, pessimistically biased, which will be error will be high. Gaurav, Sachin, Pratik, read the question properly. Now, can someone answer why B? If I'll have the, we have done, if I train it, if I'll test it on the same training data, I'll have the low error, na? While I'll have the more error. It
Ma'am,
will be
here we thought too biased means having less error. That's why.
less error. You are right. What I'm saying is, I am training Pratik, I am training on some data set and I'm testing on the same data set.
I didn't understand the question, so
So
I.
there should not be any error, right? I mean, this
That,
is the data is same.
that
Uh,
is too
then
low. Too low. That is what optimistically biased. That is what it is saying. Gaurav, you got now the question? Gaurav?
Yes, ma'am. If you use a true, we are testing with the training data itself to estimate the error. Got it.
Please, everyone. Sachin, you got it? So please, everyone, read the question properly in the exam. A single training test set may lead to unreliable estimate because it uses a replacement. It has high variance depending on how the split is chosen. It doesn't allow decision tree. It over penalizes the minority class. This is very simple. Shamil, please write question number. It's actually B. Uh, almost everyone has correctly answered that it has high variance depending on, because we were thinking, okay, because it depends on the split, how lucky or unlucky is the split. The motivation behind using multiple training set is to reduce model bias, to simulate drawing multiple data sets from the underlying distribution, to increase the training error, to avoid using the testing data. Maybe it's confusing. Yes, come on.
Ma'am, if
Why?
I may, ma'am, I always thought that we were using multiple data sets so that it would simulate underlying distribution. But towards the end, we always average it out. So that's why I thought it's reduced model bias.
Though it's like it's as you thought that it is simulating multiple data sets from the underlying distribution. It is correct. But what about bias? Yes.
I actually thought that because we in the end always average out all the
Bias
same
means
model
bias.
and
Bias means, can I say like how far it is from the goal? Can I say like true error? Can I say what is bias? Can you tell me?
yes, it's away from the true error. It
True
has
error.
its own yes.
So we can't say that sometimes it will always reduce the model bias by taking multiple training data set. But it doesn't change the model itself. Uh, like it will not make the model more flexible. It will not contribute something to the model. It only changes the data on which the model is trained. Though I can have that variance and all, which can be lower. But if I talk about model, if I say that model itself is not performing good on one data set, will it perform good on multiple data sets? Though it reduces variance, that is true. It do reduces variance. But about bias, model bias,
Okay,
model bias. If
okay,
it's not performing on one data set, it will not perform good on multiple data set as well. Are you getting my point? Please
got
read
it.
now again. Model bias. In k-fold cross validation, each data point is used for training once, never for testing. Used for testing exactly once and training k minus one times. Never used for testing. Used for testing multiple times. Easy only. Though I haven't explicitly mentioned, but I have taken an example and told you. Exactly. Everyone is correct here. B. In stratified cross In stratified k-fold cross-validation, each fold has same size but the random class distribution. Each fold preserves the class proportion of the whole dataset. Only minority class examples are placed in test sets. Training data is ignored. Please be fast. This is also simple one only. Now only I have mentioned. Yes, yes, come on everyone. Exactly. You are correct. Each fold preserves the class proportion. That is what I was trying to explain just before this MCQ. In Bootstrap resampling, each Bootstrap sample is of size smaller than the original dataset, equal to the size of original dataset, larger than or randomly varying. Simple only. Exactly. On average, in Bootstrap sample, the fraction of unique points are though it may not come, just for the information. The out-of-bag data in Bootstrap refers to data used for training, data left out for use for testing, data discarded permanently, data reserved for cross-validation. Till this point, everything is clear? Come on. Clear? Okay. Let's start the next topic, which is very important, confusion matrix, which is used for evaluation so much in machine learning. In each and every paper, you will see these matrices basically. So what is this? Okay, let's be fast. I predict some class and something is called true class. Do you guys know what is the difference between predicted class and true class? Come on.
So predicted is something which model has predicted. True is actually the actual answer or what really exists.
Yes. So true positive. Okay. I'll give you a simple trick. Whenever I'm writing this, let's see a simple trick. Whenever I'm writing this will be always predicted one. This go from right to left, which means it has predicted positive and it is true, which means actually it is positive. When I'm writing false negative, which means it has predicted negative, but it is false. Am I correct or yes, yes, yes. But it is false. It is actually the true class is positive. Now, can someone tell me about false positive? What is the predicted class here? And what is the true class here?
Predicted class is true, but the no. Yeah, physics predicted class is true, but the true class is false.
Positive. You can see this. Here's go from right to left. It is positive. True classes. Negative, can I say?
Yes.
Does it make sense? Like,
Yes.
actual class, predicted class. Always move from right to left. And this one will be the predicted class. Predicted class, positive. And it is true, which means actual class is positive. Now, can you tell me predicted classes? Everyone? Predicted
Positive,
positive. Classes,
false,
false means,
negative.
which means I predicted it positive, it was false, which means it was negative. I predicted it negative, it was true, which means it is actually negative. I predicted it positive.
Ma'am, your sound has decreased.
Am I audible now?
Yes, ma'am.
For others?
No, ma'am. It's still
It's
coming through.
it's
Yeah.
as if your mic just went very far from.
Okay, I'm here only. Okay.
Yeah.
So,
Or you went far from.
okay. Now it's fine.
Yes. Yes.
So, my predicted class is positive, but it is false, which means my actual class is negative. Any doubt?
No, ma'am.
Ma'am, you have written wrong in the
No,
third
that is
step.
what I'm thinking. Something is wrong somewhere. Oh, nothing, nothing.
Third part.
Actually, it was false negative. Huh? I predicted as negative, but it is actually false, which means it is actually positive. Is
Ma'am,
this
I think
concept
ma'am the wrong is in third.
third? Okay.
Ma'am, yes, ma'am. Ma'am, the true class is positive
Hmm. True,
and you
why
have
true
written negative.
positive? True negative. Okay. True means don't. Okay. Pratik, don't get confused. Again, I'll explain what do I mean. This is the main. What do I mean? True negative. I got it where you're getting confused. Predicted is negative, and you are predicting it right. True means you're predicting it right. which means this is actually negative. True means true doesn't mean plus. True means whatever you have predicted is correct.
Okay.
False means whatever you have predicted is incorrect. Now you got it? Negative means I have predicted it. I'm repeating it again and again. I am sure that one question will come from this confusion matrix. Okay. And further concepts are related to this only. First, you have to get it. So, predicted is negative and you are true, which means you have predicted it correctly, which means negative. Now, can you answer false positive? Predicted is positive and you have predicted it wrong. False means you have predicted it wrong, which means it is negative. False negative means you predicted is it negative. What is actual class? Now, can someone tell me true class or actual class? Come on, come on. What should be the value here?
Positive.
What about others? Everyone got it? Why positive?
Yes, ma'am, positive.
Why positive?
Because negative was false, which is wrong. Like negative was wrong.
Yes. P means true positive. You are predicting it correctly. Positive. Not that you should not see here F and here you should say minus, negative. Pratik?
Yes, ma'am, got it.
Got the concept? Please don't forget an exam what I have told you. This is predicted and this is are you correctly doing it? Are you incorrectly doing it? Not that this is the actual class. So this is what I have written here. Okay. Let's try to do. Okay. This is just the confusion matrix. This is the same thing, nothing else. Okay. Like these are predicted positive, true positive, so nothing else. The same thing I have written. So now one example, we build a classifier to detect if person has flu based on symptoms. My voice is fine now?
Yes, ma'am.
We build a classifier. We have to predict whether the person is having the flu or whether the person is not having the flu. We test on 10 people. 6 were actually having it. So which means that it is true positive and 4 were not having it, which is it is truly negative. Not true positive. I mean to say uh, the true class is positive and the true class is negative here. The 4 are not having. Classifier predicted it. 5 people having flu positive, 5 people having flu negative. Coming to the detailed result, so among the 6 true patients, 4 predicted correctly, 2 predicted negative. What do I mean to say here? 4 predicted correctly. Wait a second. Just 1 minute. Yes, yes. Sorry for the disturbance. So, can someone tell me what I have written here? True, negative, and wait a second. True, positive, and false, false, negative. Are you getting it now? This is very important concept. Okay. Among 6 true patients, which means that whosoever were having the flu was true, whosoever were tested positive, true positive class, 4 were predicted correctly. So, which means out of 6, 4 were predicted correctly, which means actually they were true and they were predicted also truly, which means actually they were having the positive class and they were having the positive, they were predicted also positively. So can I say they're true positive, which means predicted positive, predicted positive, and actually they are true. If I'm saying that 2 predicted negative, which means they are predicted negative, but they are false. This prediction is false because actually they are true. Does it make sense?
If actual okay, yes, false negative, yes.
Yeah, I mean it was positive, but it has predicted negative, right?
Huh, huh. So we'll come from right to left. As I've told you, go from right to left. What they have predicted? Negative. But ideally they were positive. So it is false. They are falsely predicted. Fine. Please give thumbs up if you have got this concept of true positive, false negative, this one. Only 2 thumbs up yet. Prateek, Megha,
No, ma'am.
any doubt? Okay. Okay. So now, coming to this one. 4 healthy patients were there. Now, 3 were predicted correctly, which means 4 healthy, which means they are the flu is negative, and they are predicted also negative, which means they are truly true negative. The prediction is negative, and that is true. Which means okay, I'll not say true, which means the prediction is correct. One predicted wrongly, which means what have they predicted? Positive. Wrongly means they were negative because they are healthy. They are predicted positive. So I'll write the prediction. And is this prediction true? Correct? No, this prediction is not correct. So it is false positive. Any doubt in this? Come on. Come on, come on.
So just that here positive means they are sick and negative means they're not sick. So
Yes.
yes,
Positive means flu, like COVID positive tested, flu positive tested, like this. Okay, na?
yes,
So
ma'am.
this true negative, false positive, you got the concept. I try to explain with an example so that you should get this very well. Okay, now coming to metrics, some for the evaluation. So this is just the theory part. The misclassification rate. Misclassificate rate or misclassification rate, it's like how much you have misclassified it, how much you have wrongly classified it. Wrongly, which means that obviously this is false. So whether I'm predicting it wrong, whether I'm predicting it negative and it is false, and I'm predicting it positive and it is false, can I say that will be there over total, the number of. So if I say that total 10 patients were there, and I'll make a confusion matrix here. First of all, I got this information. I got to know this is true positive, false negative, true negative, false positive. I'll make a confusion matrix. How I'll make? I said that true positive. I'll come to here. 6 true patients, which means 6 patients are true. Okay. And 4 patients are negatively tested. Predicted positive, 4 patients are predicted positive, and we know that this is true positive. 2 patients are predicted negative, so this is false negative, we have already seen. Which means true is positive, predicted as negative. True is negative, we have seen that this is false positive, which means that one was predicted wrongly. Just I am writing the values. Is this confusion matrix fine? Have you understood it? Come on. What about others?
Yes, ma'am.
Please give thumbs up. So now misclassification rate will be whatever falsely predicted is there. So whatever falsely predicted is like false negative, we'll make a confusion matrix. We'll have false positive, false negative over total. So 2 plus 1 over 10. That is 30% of misclassificate rate is there. Next is accuracy. Accuracy, obviously, if misclassificate rate is false negative plus false positive, can I say accuracy is true positive plus true negative? Which means whatever was the positive and it is predicted correctly, whatever is negatively predicted and it is correctly predicted, that are basically true positive and true negative. So which are 4 plus 3 divided by 10. So this kind of case study can come, example can come in exam. So next is precision. First of all, tell me, are these two metrics clear? Misclassificate rate and accuracy? Can someone unmute and tell me?
Yes, ma'am. Clear. Yeah.
Yes, Gaurav?
Miss, yes, ma'am, it's clear. The last three, though, last few are not clear, ma'am. So,
Okay, precision recall. Okay, I'll come.
yeah, so,
Precision. So, so many misclassifiers are positive class. How many are actually positive? What do I mean by that? Here, precision, we are only focusing on positive classes. We are not focusing on negative classes. What I'm trying to say, there are many positive classes, but how many are actually positive classes? Which means there are many people who are predicted as fluke positive, but how many truly are positive? So, what will be the precision here? Think of, there are many classifiers having positive class, how many are actually positive? So, what are predicted positive? Whichever will have right hand side as positive, these are predicted positive, these both are predicted positive. Does it make sense? Come on. Yes, Pratik, Gaurav, Sachin, Shamal, yes.
Yes, ma'am. Whatever is truly positive by whatever we thought was positive.
Yes, yes. That's are these predicted positive? We thought that these are positives. Both of them are positive. Now I want to tell you, I want that how many are actually positive from from whichever we have predicted it as positive. So that is true positive over true positive plus false positive. Is the precision clear? Next is recall. There are many positive points in data, out of which for how many classifier is actually telling you are positive. What do I mean by that? So there are many positive points in data.
Ma'am, sorry, ma'am. Hello.
Yes, 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 George.
What was the second one?
Okay, precision. Okay, accuracy
Uh,
was
yeah. What is the N? Yeah, N at the
total
what?
number.
Total number. Yes, ma'am. I confused it with the negative. Yes, ma'am.
Okay,
Okay.
is it fine? Okay, let's.
Yes, ma'am. Yes.
So, precision. So it's like true positive over. Okay, sorry, recall. So what I'm trying to say, there are many positive points in data. How many are positive points in data? Actually, positive points in data. Can I say they both are positive? How false negative is positive, true positive, like actually positive? Can someone tell me so that I should know you are actually getting the concept?
Yeah, it is negative, but because it's false, it is actually supposed to have been positive. It came out as negative.
So actually it is positive, na? So I'm trying to say which are actually positive. True class is positive. So can I say for both of them the true class is positive?
Yes, ma'am.
Hmm. So how many are the positive points in data for which how many of the classifier is actually telling you? So how many the classifier is actually telling you that is true positive? From how many are total actually positive? Does it make sense? Yes. Yes, George, Gaurav, Pratik, Sachin, Shamal, Krisha, yes. Sachin has got it. What about others? Gaurav,
Yes,
you
ma'am.
were.
Got it. Got it. I was writing it down.
So now uh, we have these four matrices. Metrics. I hope so that these are clear. Misclassification rate, accuracy, precision, recall. Now we have some PR curves. I'll come to that. These are like precision recall curve. And okay, I have these are usually when we do some machine learning, people usually plot this PR curve, this precision recall curve, and what they try to have is the trade-off between precision and recall. Can you tell me what why to have a trade-off between precision and recall? Come on, let's try to figure it out.
Ma'am, it's a difference between what came as positive and what is actually positive. So that is already like what is true and what is predicted. So they are different. If they are same, then recall and precision both would be same.
Okay, okay. So, do you got what is the main objective of recall precision trade-off or no?
Precision would be out of whatever is true, what is
Whatever is predicted true, precision is.
okay.
Actually,
How many are actually true?
precision is basically uh, there can be actual positive and actual negative. So
Hmm.
out of them, how many are actual positive? That is what precision is talking about.
and we are predicting them positive. Yes, yes, exactly. So of all the samples predicted positive, how many of them are actually positive? Now recall is out of all the actual positive, how many we have correctly identified it. Can I say?
Yes, ma'am.
Now let's come to specificity, the another parameter. Can someone tell me now? Can you explain me what is specificity? Come on, fast.
Basically, it is equivalent of recall
No, no,
in
no.
in
Okay,
case of negative prediction.
okay. Out of actually negative, how many did we classify it negative? So, okay, okay, yes, exactly correct. Out of the same way, out of actually positive points, how many of you have correctly told positive? So, specificity is how many of actually negative, how many you have correctly classified as negative. Any doubt? Any doubt in all these parameters, metrics?
Ma'am, I have a note here written
Come.
specificity is equal to recall. Is that correct?
No, no. Specificity is equal to recall, which maybe you have written. Recall is same as specificity, but recall is talking about positive class. Specificity is talking about negative class.
Okay, okay.
See here. Out of actual negative, how many are? How many of out of predicted negative? Sorry. Out of predicted positive, how many are actually positive in recall? Specificity. Out of predicted negative, how many are actually negative in specificity?
Okay, ma'am.
Positive, that is negative, talking about negative class, and this is talking about positive class. So actually they are same. The I'll say the concept is same, just talking about the different classes.
Okay, ma'am.
Any doubt till now? Any doubt?
Ma'am, we'll find out the doubts in the question answer part of this.
Okay, okay. I'm just going to come here. Okay. So ROC curve. So it's like true positive rate and false positive rate. Can someone tell me what is true positive rate? Is it like the same as recall, and what is false positive rate? Can you it is 1 minus specificity. Can you check and tell me like what is this? Come on. Tell me what is false positive rate, what is true positive rate. Come on, guys.
So TPR is actually recall, right? I mean, the both
Recall.
terms are
How
same,
many
TPR
are
and recall.
True positive rate is whatever came true by whatever is true, and false positive rate is whatever is false by whatever came false and whatever is false. Like,
So
okay.
false positive is actually negative.
Hmm.
So actual negative over all possible negatives.
Mm-hmm. Okay. So you are correct by saying the recall. Yeah, I'll come to your statement.
an FPR is whatever came wrong by whatever
Was
is
wrong. Was wrong.
whatever came wrongly in class, positive by whatever should have. I'm not sure. I'm not sure FPR. Suddenly, it just doesn't make sense.
Yeah.
So
What?
true negative is actual positive.
True negative. Okay, let's come. As you are saying, okay, true negative is actual negative.
Actual positive.
No, 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 negative, negative. Okay.
Sorry, actual negative, and false positive is actual negative.
Hmm.
So whatever was actual negative over what falsely predicted as positive.
Hmm. What was specificity? Okay, I'll not come to 1 minus, though it's 1 minus specificity. So what is there? How many positive points are misclassified? Can you relate with that? False positive means it was positive actually, but I predicted it as false. Sorry, it is predicted it as positive, but it is false. It is actually negative. Can I say I have misclassified it? The negative one. This is false positive. It is actually negative. Come on, come on.
Yes, ma'am.
And false positive. And what is FP plus 2 TN?
Total outcome of negative.
Actual negatives, total of
Total
actual.
actual negatives, yes.
Can I say like I'll write the statement. Among
Looks like whatever came falsely came in class 2 by what total of whatever came in class 2.
I'll write. Will not get confused. If I say that true negative is suppose 950, which is correct. Okay, okay, 1 minute. I'll have a statement here. Suppose I have 1,000 people testing, 1,000 people for testing, and true negative 950 correctly predicted healthy. They are negative tested, which means they are correctly predicted healthy. Got it now? Like the negative tested. And false positive means which are the wrongly predicted sick. Which means they are not sick, can I say? They were tested positive, but they are not sick. They are actually negative. Can I say they are wrongly predicted sick? Does it make sense?
Yes,
Come on.
ma'am.
Now,
Ma'am, actually, I think in case of this example,
wait a second. Wait, let me write and then. So, can I say 50 plus 950? So, 5%. Can I say among all healthy people, which were negative, all healthy people, 5% were wrongly flagged as sick, 5% were wrongly. Does it make sense? Now continue. Yes, yes, Sachin.
no, no, madam. Actually, I was trying to say, in the case of these medical examples, actually negative means the sign of healthiness,
Yes, yes.
and that's why we are saying um, true negative
Hmm.
uh, is predicted correctly. It should be actually. I mean, we should convert this problem to actual true and false in terms of prediction and actual. So
I'm getting.
yeah, we should. I mean, in the case of patient example, it is confusing.
Reverse, huh.
Yeah, we should not use patient example.
Maybe you can use some other, though it's negative, and do try to understand about the class. It's negative, and we are actually predicting it as negative. The test was negative, it was predicted as negative. The test was positive, and it was wrong.
We can pass fail student pass fail example. We can do it.
Though we don't have time, so that's why I'm rushing up. So this is basically among all the students which were failed, how many I have like those who
Wrongly classified as failed.
wrongly classified as failed. Actually, they were passed. Fine. Does it make sense?
Yes, ma'am.
So this is basically as false positive rate, and this is also called as 1 minus specificity. Specificity was if I go, which were truly classified as negative. Here, which are wrongly classified as negative, like which are actually, with please, okay, I'll tell you, okay, go through this specificity and FPR and see how it is 1 minus specificity. I'll not go in detail right now, though it's like true negative over true negative, you'll get to know. Fine. Should I proceed? Come on, come on.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
So all these metrics, sensitivity, recall, true positive rate, false positive rate, precision, misclassificate rate, all these are clear. There are high chances that something can come in exam from this. Is it clear now?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah. So when TPR, true positive rate, is 100%, what does it mean? Can I say when TPR is 100%, TPR means, let's first write the example whenever it is given, which means that true positive over true positive plus false negative, it is equal to 1. Which means,
Everything that is supposed to be in class one is correctly classified as class one. That's what I'd say. Like, if everyone who's supposed to have passed have passed.
so no one has failed, can I say?
No, ma'am.
Uh, so everyone actually, all are actually positive, can I say? So, wait a second. Maybe, yeah. Okay. So how it can be like, do you remember the concept of threshold in supervised learning? Like, what is the concept of in classification? I mean to say, not supervised learning, in classification, threshold concept. Anyone? If it is above this, nothing. It's like, is it, if it is above this, then I'll term it as positive, and if it is below this, I'll term it as negative. A very first class, what we say, that okay, if it's his income is greater than this much threshold, I'll say that this belongs to positive class. If this is below this threshold, I'll say this belongs to negative class. Does it make sense? That was the threshold.
Yes, ma'am.
So when the threshold is very high, what does it mean? Or very low? If the threshold is very low, can I say that threshold very low means that all are positive? Okay, come to first threshold is very high. I'll come to lower threshold. When the threshold is very high, what does it mean? Above this are true class and threshold is very high. Which means very few classes will be positive. Does it make sense?
Yes, ma'am. Means very
Come
few
to
chances that that anything will come as positive class if the threshold is very high.
exactly. Now I have written in that class true positive rate will be low. Does it make sense? And false positive rate will be low. What does it mean?
The threshold is very correctly put.
Uh, no, threshold is not correctly put. It is put by me while modeling. Actual class is not that much. I am saying I am putting that threshold. Wait. Okay, let me say that suppose actual is like, if it is above 50, then they're positive. This is actual correctly classified. And if it is less than 50, then negatively classified. But I am putting the threshold as above 90 because I am learning it. So in my learning model, I am putting it above 90, they are positive, and below 90, they are negative. So what will happen in this case? That is what I am saying.
Overfitting. Yeah.
No, overfitting, nothing. Why overfitting? Uh, let's talk about true positive rate and false positive. So if the threshold is very high, which means my positive classes, can I say whatever was between 50 to 90, which were actually positive, they are now by my
Lost.
saying as negative, not lost. My model is saying as negative.
Okay, so they are false negative.
False negative. Exactly. Can I say?
Okay. Yes, ma'am.
Can I
Got
say
it.
this false negative is high and true positive will be low? Come on.
Yes,
No,
ma'am. They are
ma'am.
actually positive.
This
No,
would mean that true positive is and false negative is no low, which means that maybe the threshold is really far down.
no. When the threshold is high, what I understand is when the threshold is high, true positive becomes less. Am I right, ma'am?
Yes.
So below that,
Hmm.
false negative is high. Am I
Yes.
right?
Yes.
It was predicted negative,
Yes.
but actually it is positive.
Yes. Yes, George, you're absolutely correct. Gaurav, do you got it? Did you got it? Did you get it or
So if
no?
the threshold is, for example, high, then true positive will be less, false negative will be high. I got that. You
Got it.
when you showed the example of TP by TP plus FN is equal to 1, that means FN has to be really small so that it's only TP by TP is equal to 1.
Yes, that is when I'm saying true positive rate is high. This was case one. Now I'm coming to case two. When
Okay,
I
okay,
have
case
high
2.
threshold, then I'm saying that my TPR will be very low because this will be low,
High,
basically
false
false
negative will be high.
high.
Yes, got it.
My false positive rate will be low also. What is false positive rate? Because my false positive over false positive plus true negative. Hmm. So now true negative are high in number, but my false, okay, falsely positive. Okay, I'll not come to FPR right now. Maybe false positive. Okay, I'll not come to FPR. Let's try to say what when the threshold is very low, what will happen?
Wrong points will also be classified as
There'll
positive.
be false positives.
There will be false
Yes.
positive. I'm predicting as first. Yes, yes. So can I say my mm, 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 this okay, true positive. Let me write true positive over true positive plus false negative. What will happen to true positive rate? Okay, let me tell you. Okay, this was true positive rate we have already seen. Okay, what will happen to my false positive rate now?
If threshold is low, right? False positive will increase a lot.
Shall I say false positive rate will be increased?
Yes,
Yes.
And okay, and true negative will decrease. Does it
yes.
make sense? No? Okay. So these were some concepts of threshold and false positive rate and true positive rate. I'll not go by diagram, just make you understand about these. Okay. Uh, Lower threshold, false positive increases. Okay. Does it make sense? False positive rate keep increasing while true positive rate. Okay. This is fine. Is this threshold concept, false positive rate, true positive rate concept clear?
Yes, ma'am. Yes, ma'am.
The last one is not clear, ma'am. And threshold is less.
Okay. Yes,
That
yes.
point alone, can you explain it again, please,
Yes,
ma'am?
yes, sure. If threshold is less, which means that, okay, I'll come to this example again. Wait a minute. This example again. So I was saying that if it is correctly done, then it is above 50, then it's positive. Now I make the threshold less while making the model. So now I'm saying if it is correctly done, by learning, what I'm saying, if it is greater than 20, then they are positive. When they are less than 20, they are negative. Now, what I'm trying to do is, they actually, whenever suppose they're 30 to 50, they'll be the points, they'll be also classified as positive, but actually they are negative. Can I say that? Yes, come on. Who was asking? Yes, who was asking the question? Yes.
Yeah, ma'am, I had asked,
Yes, yes.
but
Uh-huh.
it's greater than now the threshold has been reduced.
Reduce, yes. Hmm.
Yes, ma'am. So
Negative.
still the same thing holds good. Does it hold good?
No. What I'm saying, it was less than 50 was a negative class. Okay.
Yeah.
Now, whatever it is between 30 to 50, 20 to 50, whatever is coming, I'm predicting as positive, but actually it is negative.
True. Yes, ma'am. Yes,
Huh.
ma'am.
So
Yes, ma'am.
now I am predicting negative classes wrong. Can I say?
Yes,
Which
ma'am.
means that I'm
Yes.
predicting as positive and it is false. It is actually negative. So my false positive are actually increasing here. So that's why my false positive rate increase. Does it make
Correct.
sense, George?
Yes, ma'am. Thank you, ma'am.
Now, uh, mhm. Okay, these you can go through. Okay. This is nothing. Maybe this is just the diagram. You can go through. These are the examples. These are nothing. You can, or maybe I'll go through one. Just a second. So at threshold 0.4, 6 are positive, 4 are negative. So suppose I take a threshold 0.4, 6 positively predicted. Okay, this is nothing. These are these only. And just I'll try to make you understand what I have done here. Uh, these are true positive rate. This is false positive rate. This is ROC curve. And can someone tell me what is the full form of ROC? Come on.
Receiver operator characteristics curve.
Yes. So this is actually the ROC curve here. And as we have seen that how true positive rate and false positive rate actually increases, we have seen. And if I talk about this line is just because both are increasing, this line is just a random guessing, we can say. And below the diagonal, if I'll say below the diagonal line, anything will come that is basically worser, and if it will come above the diagonal, which means that true was like it will be basically better than the random path. Can someone tell me why above the diagonal it will come, it will be better, and why below the diagonal it will be not better? Do I want my true positive rate should be greater or lesser?
Greater.
Greater. So whatever will my true positive rate is actually increasing here. That is what my main motive is. So that is what I'm trying to say. If it will come above the diagonal, it is actually better than the random part. And if it is below the diagonal, it is actually worse than the random guessing also. So now we come up with the area under the curve. Can someone tell me what is area under curve? Come on. Yes, you'll get the similar kind of question.
FPR.
Okay. Yes, yes, come on. What is AUC?
More the area under cover, more will be the TPR.
Yes. More will be the better. Classifier will be more better. With whatever the model we are using, that will be more better. Can I say?
Everything under the curve should be okay. TPR. You want true to be more accurate. Okay, got it, got it.
Yes. Got it, na? True. Because if I'll have this line, then area under curve will be low. If I'll have this line, the area under curve will be lesser. Does it make sense? So rather than seeing, I can say that, okay, whatever, let's say, let's have a metric called area under curve, and whenever it is more, I'll say that my classifier is better. Does it make sense?
Yes,
Yes.
ma'am.
Come on. Okay. Now, now, let's see. Um, so let's have an example here. Let's suppose I have a true class positive. So true class positive, I'll go above true positive rate, maybe. Sorry. I'll have this threshold. This is threshold. So above this, they all are positive. Above, below this, these all are negative. So what is it? Wait a second. Let me write true positive. What is true positive rate? True positive over? Come on. You got this formula, na?
Yes, this is TPR.
TPR. We call a TPR. So above this, I took this data set. Above this, suppose I say that above I took this threshold. Above this, all are positive, and below this, all are negative. So, can I say that what is my TPR if I'll take this threshold?
Very high.
It will increase because my positive is actually predicted correctly. True positive is high. Come on, tell me. So I come up with the one above. Now I took this threshold. Again, I have predicted it correctly. I come one step above. Again, I have predicted it correctly. When I took this threshold, I come one more step above. Now I took this threshold. I took this threshold. Now, can I say I have predicted one incorrectly? It was positive actually. It was basically, this is negative, and I'm saying that it is positive, which means I am predicting it as negative, but it is actually positive. So false negative will increase. So right hand side. Till now, any doubt? Or I should make it again? Come on.
No, ma'am, don't make it again. But why are you doing that?
I'll come to that. Are you able to understand what I'm doing first of all?
Yes, ma'am. If it's
Yes.
true positive, then you're going up the y-axis. If it is
Why I'm going
false
cross?
negative, yeah,
Are you getting or no?
be- because y-axis represents.
The true positive rate is increasing. Can I say this is
Okay, yes, ma'am.
positive rate? This is false positive rate. Are you getting now why I'm saying?
Yes, ma'am. Got it.
So here, if I come, I am predicting it as negative, but actually, I'm predicting it as positive. Why? How I'm predicting it positive? Because what I'm saying, this is threshold, and data points above the threshold they are positive, but it is actually negative. So I'm predicting it as negative, but it is false. I'm predicting it as negative. Sorry, does it makes? I'm predicting it as positive. What should it be? False positive or false negative? Come on, can you tell me?
If false positive or false positive, you're
False
checking it as
positive.
false.
So my false positive rate will increase. That's where I was. So false positive is PP. Sorry, FP over FP plus PN. So can I say my false positive is increased here? I'm going to right hand side. Come on.
Yes, ma'am.
No,
Not
that
sure.
was very slow. Okay, that's why I'll make it again. Okay. Plus.
Okay, ma'am. Because you're going on the x-axis, false positive rate is given over. That's why false positive might be increasing, is what you're trying to say.
What about others? Are you getting this or not?
Yes, ma'am.
What about others? Only Gaurav is getting it. Pratik?
Ma'am, I have one doubt. Ma'am, is
Yes,
this
yes.
ma'am positive? Is it ma'am true class or our predicted class?
This is true class. Okay. True positive rate, false positive rate. Pratik, you got it?
Yes, ma'am.
Yes, yes, okay. You have got it. Now, what I'm trying to do is saying that let's put the threshold here. Whatever the classes above it are positive, and whatever the classes below it are negative. That's what I'm saying. Say about true positive.
Ma'am,
What
that I got it, ma'am. Ma'am, this part I got it. Is only want to ask that ma'am, is it positive or true class or predicted class?
okay, okay. True class or you're saying this is actually true class. These are true classes.
Okay, ma'am, I understood.
Now, what I'm saying is I'm predicting whatever is above threshold as positive and whatever below threshold is negative. Understood? Whatever. So that's why when I came here, I said whatever above is positive. So, but actually it was negative. So that's why my false positive was increased. That's why I shifted right.
Yes, ma'am.
Does it make sense now? So
Yes,
this
ma'am.
is how I have made it. And if it is above this line, so which means it is better than the random. So this is the ROC curve, like how we usually make this ROC curve by taking different thresholds actually.
Uh, what,
I'll
yeah,
come.
what's the significance of ROC if you can?
So this is just the true positive rate and false. I'll come to you. I'll come to you. I'll come when I'll solve this. So okay, or someone can answer what is the significance true positive rate, because I want to get what is my how I'm predicting it truly. I want that whether my model is performing well or whether my model is not performing well. If my model, if this is above my diagonal, I can say that I am performing well. My true positive rate is better than the false positive. Like they are going above. I'm truly predicting whatever it is positive. So my classifier is actually performing good. Can I say?
Ma'am, can there be a possibility that the chart
Hmm.
will initially it is towards the range of TPR, and then it crosses this line, comes into FER, and then again goes
It
into,
goes like this.
yeah, I mean
It
somewhat
can,
like this or some, yeah.
can be. Though when it has reached here, it will go like this only. Like this is like how we'll have this threshold at every step and construct it. I'll come to how we'll do it. How we'll do it. Let's take an example, a quick example. This is a true label and this is a classifier which is predicting it. Like I'm taking the data point and my classifier is predicting it. So true label, it is positive. My classifier predicting it as 95%, it is predicting it as 1. My true label is negative and my classifier is predicting 85% as 1. These are different classifiers I'm using. Okay, this was one by one classifier I am having this ROC curve. First of all, tell me this ROC curve, have you got it? Come on, come on. Come on, class.
Yeah, just I mean, in this example, as this with this example, I could understand that threshold. We have changed the threshold, and then we have plot. But in actual practice, we have to keep on calculating TPR, FPR, and plot those points, right?
No, I'll come to. And that we have to calculate this TPR, FPR. This is like by this only, no? By this threshold we'll do. I'll come to that, how we'll do actual practice. I'm coming to that. This, that's why I'm coming to the class, actual practice one, this example. Till now, can you tell me, is this classifier, is this ROC curve, sorry, for one classifier, have you got it? Yes, Gaurav?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So now I'm taking different classifiers, A, B, C, D, E, F. They are predicting 95% as okay, fine, if my true label is positive. And if it's negative, it's predicting it as positive, that is 85%. Like they do like this. So now what I'm okay, one minute, not classified, sorry. Wait a second. Something I am missing here. Wait a second. Maybe I'll explain this example. I got confused by the classifier of the data points. This point, is it clear to you? This point till this point. I'll come to the real-time example this in the next class. Till this point, is it clear?
Yes, yes, ma'am.
Yes, ma'am.
So please solve this. Though I have given so many MCQs, simple MCQs. These are like the simple one. The simple, I'll say, what is this? The F1 score, something is added. You can see here. And these are the simple MCQs. And these are something like which I have given you like 200 emails or like the healthy, unhealthy examples, some case study like MCQs. So that you can able to solve like below the diagonal line, so that you can able to solve both of the type of MCQs in the exam. Then what is left? Minimum description and ensemble methods are left. Maybe I'll record the video. I'll try. I'm not sure, but decision tree. Okay. I'll try. I'll record the videos of this ensemble methods, and so that you can see in the next class, before the next class. Is it fine for you guys?
Yes, ma'am.
And this example we'll study in the next class. And MCQs, though I'll not discuss in the recorded videos, it's I'll tell you, please go through them and ask me if there was any doubt in them. Decision tree also I have uploaded, and please go through them also, decision tree MCQs which were left. And ask me, because that is the next class, is the last class. Okay, and one more thing we can do is, wait, let me stop the recording.